So you found the skeleton. How would you tell it to represent you personally? How would you decide?
Well, interesting question. I don't know. I'd have to do some research on that.
All right, hello everyone. I am here with Leo and Ross. I am expecting at least one more person. I know that a few people have asked to join, and I will be opening it up after a half an hour, assuming that we still have open spots. And so I'm hoping to get as many people in as possible, but I don't have the premium version of StreamYard, so you'll have to forgive me. I won't be able to get more than 6 in. And for at least the first half hour, I'm going to be keeping all of those spots reserved for the other panel members. So there you go. I do want to say, before we get going, I did have a super chat from Carrie Bronson for $5, who said, "All shall kneel before the void." That is accurate. Ross, Leo, did you know that I accidentally started my own religion? It's the Church of the Void.
Uh-oh. Oh, no. Oh, no. This isn't good.
Yeah.
He's got his own religion now, guys. Everybody run for cover.
All it takes is you to acknowledge that eventually the void will consume all, and also to occasionally give me super chats, and then you could be a member of the Church of the Void. No, it actually happened because I neglected to hit stop streaming on OBS one day. And so eventually YouTube just decided I was streaming, but all it was just a black screen with no audio, and that went on for over 5 hours. Yep.
Wow. Wow.
So, yeah, that was a thing that happened.
It definitely sounds like a void.
Well, yeah, that is the whole thing there. So what I usually do for these, for those of you who might not know, is I like to first get everyone in and ask them how they thought the debate went and if they have any initial thoughts. And that's supposed to be a relatively quick thing, but it's not exactly timed. So I'm just going to go from top to bottom, which is what I always do. I just let, like, you know, StreamYard gets to decide basically which order I go in. So we'll start with Leo. Leo, what'd you think?
I thought that our interlocutors, as some might pronounce it, there's reasons why I do so differently anyway. I thought that they were significantly, I'm going to be honest, they were much more respectful than I thought that they were going to be. I didn't hear any personal insults from them. Albeit I disagreed with their points, they were doing their best to make points, and I think that's important in a discussion. Even if you think that the points might be invalid or incorrect, at least your opponent is making an attempt to make points. I think that that's good. Overall, I think that it was a good, healthy discussion. I think that it stayed respectful, at least for the most part. Nobody insulted anybody else. Everybody kind of said what they wanted to say, and then we covered a number of different topics, about 3 or 4. That's always something that I enjoy about debates, is when we actually move from topic to topic. Overall, I would give that debate probably a 7.5 out of 10. I think it was a pretty good one.
Oh, all right. I tend to agree. But Ross, what do you think?
Yeah, I thought it was a fairly reasonable debate. I was a little bit frustrated at first, without being given an opportunity just to throw in my 2 cents worth about certain topics. And so I did actually leave the debate for a short while there and said, this is ridiculous. You know, if I'm not going to be involved in it, then
I think that's one of the I think that's one of the challenges with a 3v3 is everyone is going to bring up things, and not all of it is going to get discussed just because of the nature of it.
Exactly.
And it can be frustrating. But Paul, welcome. So the way we're doing this
I haven't seen it. G'day, Paul. Not
So-
many, but anyway, yeah,
So
still trying to give my
Yeah, it was quite easy for me. I didn't need to do a great deal.
well, so
Especially with Dapo and Leo there.
well, we
When you started getting onto the actual the science side of it, I was like, well, I'm out of this bit. I can talk about navigation, and how navigation only works.
Hey, you're better at navigation than I am. I was in the Navy, but I wasn't exactly like, you know, the guy who was plotting the course. So like I had only the basics of all that navigation stuff.
Yeah, well, the only navigation I've done is really when I was in the army, I used to do navigation, but that's not necessarily based on the globe Earth, because that's based on grid references, which can refer to, you know, that will work on a flat plane. But when it comes to navigating, whether you're on ships or using navigation in aeroplanes, Aussie Jesus, seriously, it cannot work on a flat plane.
That's fine, but I was still trying to give my explanation of what I thought about the debate in the first place. And the very first thing I said was I was a bit annoyed about being talked over, and the very next thing that happened is I've been talked over while trying to give my summary of what I thought the debate was. But I thought it was
let's give you some
minutes at least. So, it's still happening. I expect, because I am polite and I'm a gentleman, I do allow people to speak when they're speaking. And I hope that I get given the same courtesy back most of the time. And when it's not, that's when I find it rather frustrating. So basically what I was going to continue to say is that I found that a lot of the globe side of stuff was a lot of gish gallop. Like they will repeat the same mantra, that they'll parrot the same things. And I think Leo was the most guilty of that. He sounded very technically expertise in his field, and that's all great and well, but it's still just repeating a bunch of gish gallop, which in the reality that we live in, it's irrelevant nonsense that doesn't matter. I just wanted to speak about, say, relative density to explain the existence of things, but then people get into the explanation of bendy space-time and think that by, what's the word, by bamboozling us with this knowledge, this higher knowledge, this greater wizardry, that somehow wins the debate. But that's not how it works. If you can't explain it in simple terms to the common person, then I think that you lose the debate, but you might score some points because it makes you look clever. Well, I think that's the biggest problem with science throughout history of science, is it's all about the bamboozle, and the more you can convince people of your bamboozle them, and everybody just sits back in awe, oh, that guy's a genius, he knows way more than we do. That's how you win. Whereas that's not how it works. The more people you can get on your side with logic and reason is, I think, how a good debate works, and hopefully the people will vote according to that.
So, Ross, that actually brings up an interesting question that I have for you, and it's that, is it not at least a possibility that reality might be complicated to the point that understanding certain aspects of it needs to come with hard effort and work, and cannot simply be completely understood with the kind of explanation that we might give to, say, a child? Is it not at least possible that there's some part of the world that actually is complicated?
Definitely, and I think this is the point it always boils down to, is eventually it becomes so complicated that even the greatest of scientists therefore then become converted back to the belief that there must be a much higher power or source of intelligence behind it all, that basically ends up still saying the same thing that the child understands, is that God did it. And I think that the more you know, the more you realise that you don't know. Whereas, the people with the confidence to say that they do know, simply because they can convolute it so much, they haven't gone far enough down that rabbit hole to realise that they really don't know. And the more you do know, the more you realise.
Can I ask a quick question?
First, we're going to get to a quick super chat, because if I don't get to them as we go, I'm just going to forget. This is from a gentleman for $5 Singapore dollars, which, by the way, I really liked both the times I was in Singapore. I had a lot of fun there. Very, very nice place. But Aussie, this is for Aussie Jesus. I was a ship's navigator in the Navy. Celestial navigation requires spherical trigonometry, and nautical miles are constant. They do not change. You have any response?
So there's no particular question. It's just a statement.
Well, I know, but if you have a response to it, that's fine.
Yeah, absolutely. Because the very first person, this is going back a little bit, he told me many years ago, I don't know how many now, but it'd be pushing 15, I would think, who told me they believed the Earth is flat. And I thought the person was insane. This was my ex-father-in-law back when I was married, 3 beautiful children and so forth. We stayed there overnight one time at their place by the canal. He'd just retired from being a merchant sea captain all of his life. So he'd spent his whole life navigating the oceans of the world. And we're just sitting having a casual conversation over coffee and reading the newspapers. And he just comes out with that he thinks the Earth is flat. And that was the most ridiculous thing I thought I'd ever heard. I was like, how does that work? Like, all I could imagine was all this water rushing off edges and all that sort of stuff. The things that were brought up with the child to picture.
Just a quick question. At that time, why did you think, when you heard that it was ridiculous?
Because I absolutely believe we lived on a spinning ball in space. And so the very first thing then I imagine then is this flat disk in space. So where's all the water going? Those images we see of boats going over the edge, that's the first thing we think of, is we're in space. How does the water stay in? Like, it just made no sense to me, and it addled my brain for probably the next 5 to 8 years before I actually started seriously looking into flat Earth, because some people I considered highly intelligent and good friends started saying they thought the Earth was flat too, and I thought, oh, that's bullshit. This is going to be so easy to disprove. I'll easily disprove it. But then eventually I came to realize, hang on, my father-in-law, ex as he may be, he knew what he was talking about. He'd spent so much of his life navigating the oceans of the world that he'd come to realize that, yes, water seeks and finds its level. Earth is all the solid bits above that water level. And so, when it comes to using nautical miles and such, as the question that was posed towards me was saying, is that, nautical miles are different from land miles simply because you can't measure a straight line in water. You're using celestial navigation, more or less, or you're using a compass navigation. And compasses, as I've described, you use a compass to draw a circle. So with the center point at the north, that's where you put your sharp point of your pencil drawing compass, and you draw bigger and bigger circles, and each one of those circles represents a line of latitude. And those lines outwards as a nautical mile are the same, but then the lines between the latitude lines get bigger and bigger as you go further and further outwards. And so nautical miles work in one sense, following the north-south route, but following the east-west route, they get bigger and bigger. So that's my thoughts on nautical miles.
Okay.
Yeah,
now
the longitudinal lines get narrower. I understand that, but the distance still remains the same, as in 60 nautical miles is 1 degree on a sphere. So you've got what you call a great circle. A great circle on a sphere cuts through the sphere exactly. So if I take, I'll grab an apple. If I grab this apple, a great circle, no matter where you cut it, will cut this in exactly half. That would be what is known as a great circle. Yeah. Mm-hmm. So the degrees, 60 degrees on, 60 nautical miles on a sphere for the Earth is 1 degree. And then obviously if you times that all the way around, you'll get you 365 degrees. So 60 nautical miles on a great circle will always be 1 degree of curvature, if that makes sense.
Now, I have a quick question, and this is not a terribly important one, but this is for Ross, and it's because some of the one super chat has referenced it. Now, I know that you were going by Flat Earth Aussie Jesus, and you've somewhat changed that. Are you still going by that?
I just brought it in for a joke.
Okay. So
I'm quite happy to go by my real name. Call me Ross. Yeah.
Okay. Well, I just want to make sure, because I want to call people what they want to be called. I consider that to be sort of like level 1 courtesy is just call people what they want to be called.
I'm quite happy with that. That's the name my parents gave me. So
okay. All right. So we have a couple. Actually, now we're up to 3 super chats that I haven't read yet. So first, for $1.99 from Vandalia 1998, we have, how many dominations does the Void Church have? So there's 2 answers. One is, if you meant what you wrote, it's just me. I'm the only one who's in domination over the Church of the Void. If it's denominations, then I think we're still at 1. We haven't had a major schism yet. But hey, here's hoping. Because schisms make religious history more interesting. Let's see. And then Don Giovanni says, for Ross, hasn't frame dragging... I'm thinking he meant been experimentally verified. And
sorry, that didn't come through clearly.
Oh, sorry. Hasn't frame dragging been experimentally verified?
Frame dragging.
It has, yes.
That's the first time I've heard of that one.
So that is a relativistic effect.
Yes.
That involves...
Frame dragging. Yeah, if you were to imagine imagine you have a pool filled with water. If you put a ball in it, let's just say a 10-kilogram steel ball in this pool of water, if you rotated it fast enough, I think we can all agree that the water around it would slowly begin to move as well due to the friction forces of that ball rotating in that water. Objects do this in space-time, namely neutron stars and black holes. They are extremely dense. They are very, very massive objects. And as they rotate, space-time around them is actually moving with reference to the rotation of these massive objects. And those effects are called frame dragging. And we have experimentally and observationally verified these effects, yes.
Okay, so when you say we, can you be more specific, like you have personally done this?
We as a society, we as a species on this planet have performed enough of the experiments and have verified them and corroborated them over a long enough period of time to know that they are accurate and consistent observations in reality. And because of that, we can say that these things are happening, yes.
So I haven't, but have you?
Have I what?
Done these things? You're just saying we as a society.
Have I personally worked in the laboratory?
That's like a very general assumption that you assume we have done this.
Well,
you haven't done it. I haven't done it. Do you know somebody who's done it?
Wait.
All right. Hold on, real quick, everyone. Here's what we're not going to do tonight. We're not going to engage in the genetic fallacy. The fact that a particular person has not themselves done the experiment is in no way something that bears on the validity of the experiment itself. That is an option we will not allow. Now, if you think that hold on, if you think that the experiment is invalid, you're welcome to challenge it on its own merits, but you will not challenge it on the fact that the person who performed the experiment or observation or whatever else that's been published in the literature is not themselves present in the room. That is not a valid criticism for a point that has been made in the literature.
Look, I agree 100% with what you're saying, but I'd still like to know a reference towards who, so I can research this for myself. Who
that is a fair question.
When did they do it? Where is the paper published?
All right.
And how can I verify that this isn't just a generic assumption that you're making, that you assume we have done this?
Well, let's let Leo look it up, and we have a few more super chats. So for $5, Mr. Wilford says, gonna ask a more general, safe question, so that way we don't have to talk too specifically about National Socialists. Why do artillerymen have to account for the curvature of the Earth on long-distance strikes? And I think the globe Earth side is just going to flatly say, well, because the Earth is curved. But Ross, do you have an answer as to why all these artillery manuals have such corrections?
Yeah, for sure, because, you know, what goes up must come down. And so depending upon the velocity that you thrust this thing out with and its weight, you know, there is air resistance and all that. So it eventually is going to come down. And because that comes down in a parabolic arc, it can easily be interpreted to have been on a globe, if that's what you want to believe in, because you can only see so far. So if it falls down somewhere beyond your range of your limited range of view, then you could easily factor that into thinking you're on a globe when it's still perfectly explainable upon a planar Earth.
Well, now I feel like a teacher because people are literally raising their hands, but I'm going to call on Paul because he's gone the least recently. So, Paul, go ahead.
Yeah, when artillery, I was in the army. I wasn't in the artillery, but I did speak to artillery guys, and I was vaguely explained what was going on. Depending on where they are on the Earth would depend on how much they would take the rotation of the Earth into account.
Coriolis.
Now, what was explained to me was, let's just use the equator. So we agree that the equator is roughly rotating at, I think it's about 1,040 miles per hour. Yep. If you fire from the equator going north, and it's going over a great deal of distance, they need to take into account what they call the Coriolis effect. So when that missile that they're firing, that projectile that they're firing, leaves the equator and starts heading north, obviously the further north it goes, the Earth is rotating at a slightly different speed. So as it's traveling north, it would have its speed would still be traveling at 1,000 miles an hour going traveling west, wouldn't it? Yeah, it'd be traveling west at 1,000 miles an hour. But where it's going to will be traveling at a slightly slower speed, so they need to account for that. And that's basically it's the Coriolis effect. You must have heard of the Coriolis effect. So basically, if you're firing from the equator shooting north, you would have to take into account the Coriolis effect. Depending on where they are and what direction they're firing, you have to take that into account. You can look this up. when the Falklands War was on in '82, I believe when the British first started firing, they didn't take into account, and they were missing. And as soon as they took into account the Coriolis effect, they started it in the Argentine chips.
Well, that's an interesting theory, but if we're talking about the Earth being it's got a circumference of 25,000 miles. How far can we actually shoot a bullet? We're talking about a fraction, about 100 miles. You've got these rail guns today, these modern rail guns, which can shoot straight trajectories using laser pinpointed accuracy upon a target 100 miles away, which that's a heck of a lot of curvature. That's 7,000 feet of missing curvature if you can point
I would like to point out, railguns do not shoot laser straight. They still follow a ballistic trajectory. It's just that ballistic trajectory is still...
First, but it's not taking into account any motion of the ground beneath it, which is what Paul was trying to say here, is that we're trying to account for the motion of the Earth beneath them, but we're told with aeroplanes that we don't have to worry about that because the atmosphere is moving with the Earth. So you've got Coriolis with powered flight, but it goes against loose trajectories that are just shot out once, which to me make zero sense whatsoever. And we've also done experiments over quite a long period of time. The English were doing it back in the day, where they're using a cannon, shooting a cannonball directly upwards, having the cannon barrel as plumb as possible just to see how fast the Earth is moving beneath it. And in many instances, the cannonball actually dropped back into the barrel, causing a massive explosion, not a massive explosion, but a lot of damage. It's quite dangerous. The Earth is not moving beneath anything, according to actual experimentation.
Yeah, well, that would be due to conservation of energy. So if you were to shoot something straight up, it would come straight back down to where it was fired from.
Yeah, the
but
Coriolis
it doesn't
effect.
happen when you shoot it in the distance.
The Coriolis effect itself is a result of conservation of momentum.
Yeah, exactly. So the projector. So if you was to shoot it straight up, it would come straight back down to where it was fired from. If you're
in other words, going in a big parabola to come back down.
Well, it depends on how much energy you shoot it with. If you shoot something outward with enough energy, because the rotational velocity of the Earth at the equator is greater than it is as you go either northward or southward from the equator, whatever you shoot from the equator is slowly going to drift. Either if you face north from the equator, it's going to drift, I believe it's rightward, and then leftward facing south from the equator as a result of conservation of momentum, which is itself a conservation of energy.
But it didn't matter where they did
object due to the result of the fact that it's following, because it follows gravity, it's going to follow the curvature of the Earth, and the rotational velocity on the surface of the Earth varies as you go from the equator to the pole. So that object is going to drift as a result of conserving its momentum, as essentially as it traverses the standard deviations in velocity as a result of your upward movement in the curvature of the surface of the Earth.
All right, so give me 1 second. Hold on, one second. So what I want to do is, real quickly, I'm going to make a point of sort of housekeeping for chat. Then I want to hear from Ross. Then I'm going to do another super chat. So the point of order keeping is, look, I'm here on the internet as a Ceratosaurus. If you're going to question people on their identification in chat and accuse them of believing things about themselves that aren't true, or genuinely being bigoted in the chat or anything like that, nope, sorry. This is the internet and everyone gets to be what they want to be. That is why Right the Hand has been hidden from the channel. Also why I might not actually let him in the room if he comes in. So that's a thing. You don't get to tell people they aren't what they say they are here on the internet. Even less than you get to in real life. Shouldn't do it in real life either. But we're on the internet, guys. On the internet, no one knows you're not a dog. We're not going to be...
Are you saying the internet isn't real life? But to me...
Actually, I'll be fair. Yeah, I actually agree with you on that one, Ross. The internet is real life because it is a big part of a lot of people's lives. I know in the past year plus, the internet has been sort of my way to actually get interaction with people, because I've been trying to stay home as much as possible with, you know, various diseases that should not be named on YouTube and whatnot. So Yeah.
I just believe everything that we experience in life is still real life.
Oh, that's fair. But Ross, so did you have a last? I want to give you the last word on artillery and Coriolis and whatnot.
Yeah. Well, I just thought Leo was absolutely gish galloping there when he's mentioning both the curvature of the Earth and gravity and conservation of momentum. He's invoking all of these things that science says, but how about we just look at it in reality and say if we shoot something up and it falls straight back down, that's because there's nothing in motion apart from the thing itself being shot up and falling straight back down again. Now, this whole Coriolis thing is ridiculous to say that one side of the equator would go one way and the other side of the equator would go the other, because the whole entire planet that you guys still believe in for reasons best known to yourselves, despite all the evidence, it's still spinning in the same direction. It's still spinning towards the east. And so the Coriolis itself shouldn't stop the conservation of momentum and make it go any other direction than what you see. But when things that get shot straight up, like sure enough, if you shot it to the right angle in front of your momentum, you're spinning at roughly 1,000 miles, 1,040 at the equator. So you worked out the right trajectory to shoot it at a certain angle, that then by the time it falls back down, it will have caught back up with the speed you're going and will fall straight back down the barrel. But if you shoot it directly straight up, then that barrel is automatically still moving with the Earth in that particular direction, but the cannonball has now left the barrel. It is now in free motion. So the conservation of momentum does not apply. It's like saying that if you jumped out of a moving train, that you are going to land at the same place that you jumped, in front of the door. By the time you land on the ground, that door is still going to be directly behind you. But the instant you jump out of that train, the door is speeding away from you and you're falling behind the train. And so the cannonball is doing the exact same thing, because it's like jumping out of the train.
All right. So I think we have that. So we're gonna move on to the next super chat. And I know, Paul, I get it, but I did tell Ross that he would have the last word on that, so we are letting him have the last word there. So next we have for £5 from Caleb Dark, who I'm just noticing has a profile picture that seems to be a Chaos Warrior of Malice. And my goodness, is that a deep dive into some obscure Warhammer lore right there? So, you know what? Respect for having that. That is... I do not expect to see that kind of dedication to Warhammer lore normally, but salute, guy. That's pretty awesome. This is for Ross. Do you still believe the moon was created by giants who carved out the Grand Canyon and is a hollow sphere of glass?
I've never claimed that as a belief. I've always put it forward as a hypothesis, because what I see of the moon is that the craters, most of them appear as though they're almost perfectly circular, and many of them appear as though they occurred as big explosions of some sort, which to me match the expectations of what you'd see, say, of bubbles bursting in, say, boiling mud. If you took a snapshot of them, you get a certain picture of what looks exactly like a crater with a bit of a dollop in the middle, and many of the craters look exactly like that. So eventually I got to thinking, well, maybe if the moon formed as a molten sphere of boiling magma or liquid rock or whatever, and it rapidly rose into the air, and as it cooled very quickly because it gets much colder up high, then as the bubbles on the surface burst, some of them might look like violent explosions, sending out the big star-shaped effects that we see in some patterns on the moon, but the cooler ones appear as small and smaller bubbles, many within other ones, and that's, to me, exactly what craters look like. They're too shallow to be the impact of a huge explosion, and they're too perfectly circular in some instances to be random things hitting them. So I've developed the idea that maybe the moon was built or manufactured here on Earth, and the only people that could do it, because in all my years of research of various different things, it has proven that the existence of giants is quite likely, quite possible, more than likely possible, and that at one particular stage there was a certain mad genius. Some people might call him Satan or whatever, but he was a brilliant mind, a very brilliant mind. He was able to genetically engineer these scientists these giants, in the underworld where he was put into, and what's down in the underworld is all lots of lava and stuff. So maybe this thing could have been made in a massive furnace if he had the right people to do it for him, which would have to be giants to to mine that amount of raw material to melt it into something that could form into a bauble, a giant bauble, because the only things that form into perfectly spheres that we know of here on Earth are bubbles. So the moon was created as a giant bubble, and as things set into place, the bottom side of it, due to density and buoyancy, became the bottom heavy side, and that's why when we look up at it, we only ever see the one face of it, because we're always looking at the bottom side, which is slightly heavier than the top side, which may or may not be slightly egg-shaped or teardrop-shaped. We don't know. We can't see around the other side. It's too high up. But the properties of what keep the moon aloft is what keeps it, so we can't see around the sides. We can only see very, very minimally around its equator, about 5% at the most. We're always looking up at the bottom side. And so more or less, yes, the concept of giants having mined the raw materials here on Earth and built the moon is still my greatest hypothesis. It's not a belief. It's a hypothesis which I'd like to see disproved by somebody who has a better explanation for how the moon came into being.
All right,
I have that. Can I present it?
Actually, I have a couple of things real quick. One is I have sent the link to a small number of people. I will be expanding that a bit later, but we hit the half-hour mark, so there are a few people, and they're basically the people I collaborate the most with on YouTube. So they're the people who I guess I just trust the most. I think we lost Ross. Ross?
I hope he comes back.
Yeah, okay, well, hopefully Ross comes back. If not, let's see. We have, oh, here he is. 1 second.
Awesome.
Let me get him back.
Awesome.
Ross, welcome back.
Sorry,
welcome back.
We were worried.
Welcome back.
I just hit the back button to try and I won't hit the back button anymore.
You know what I do all the time? I'll be watching a YouTube video on my phone, and then I'll like grab my phone and pick it up off the surface, but my finger will just barely brush some other video, and it will start playing that, and I'm like, no, what are you doing?
Yeah. And then you go back and it sends you to the menu, not the one.
Yeah, exactly. Okay, so I mean, I get it. It's, yeah, you know what? It's very frustrating, but okay, so
sorry, what were you saying?
So I have a real quick question, and then Leo wants to go, and this does have to be a quick answer. But Ross, let's say that we wanted to find out if your idea about the moon were wrong. What observations could we hypothetically make that would invalidate your idea?
Well, that's a good question, because basically when somebody puts forth a hypothesis and they base it on sound understanding of where they came up with it from, then you pretty much just have to come up with a better explanation. You have to explain how the moon, because some people say it was a massive meteoroid or whatever, knocked it off the Earth. You have to say then, well, how did it form into such a perfectly spherical object? And I know that everybody loves to invoke gravity, but then you'll have to prove gravity. And even the greatest astrophysicists in the world, when asked what is gravity, they say, well, we don't know, but we just assume it exists. So to form something so massive as the moon into a perfect sphere, it takes a huge leap of faith to say that it can happen by random chance accident, let alone for it to be the exact same size as the sun.
But Ross, that's not really an answer to the question that I asked then. So very specifically, I want to know, what could we look at on the moon and find possibly, right? So this is in the potential future. Someone's going to check. What could we look at on the moon and see that would make it so you know that your idea is false if we see that thing? What could we do to falsify your idea? Because this is a scientific hypothesis that you're proposing. And the way that we check scientific hypotheses is first we check to see if we can disprove them. How would you disprove your idea?
Well, that's why I have my hypothesis, because I can't personally disprove it. I've tried to disprove it, and because I can't do it, that's why I put it out to other people. So if they can disprove it, say, well, as I said, if you come up with a better hypothesis or a more rational explanation that beats the one that I think is the greatest one that could possibly be imagined to the best of my knowledge, because I've been looking for origins of the moon for
right.
all my life. People told me aliens dragged it in on another back of a spaceship. So if you can find me the aliens who did that and get them to stand forth and do a lie detector test and say, oh, we dragged it in from another part of the universe, we put it there, then that would probably prove me wrong.
All right, Leo, you had your hand up, and then after you go, I want to get David Neff's impressions on the debate because he just joined us, and then we will continue with some super chats.
Sounds good. So there is a much better hypothesis out there for how the moon formed. Excuse me. It's called the Thea collision hypothesis. And about 4 to 4.2 billion years ago, very, very, very shortly after the Earth had formed as a planet, a Mars-sized object struck the planet Earth, and given the mass of this object and the velocity at which it would have been traveling when it struck the Earth, it was capable of tilting the Earth 23.5 degrees north on its axis and giving it a rotation as well as a precession about its axis. So all of those are explained by this particular collision. At the same time, the fact that the moon is tidally locked to the Earth, that is, that one side of the moon faces the Earth at any given time, the fact that the orbit of the moon is just shy of the rotation of the Earth, are all explained by this particular hypothesis. And I'm sharing my screen. I have here a handy graphic that shows exactly how this event would have occurred, and it explains. It also explains why, because we've taken samples from the moon, because we've been to the moon. It explains why it has a very similar composition to the Earth, at least on its surface.
Okay, so we're gonna go to.
All right.
Where do we see this graphic?
Well, hold on. We're gonna go to David Neff because I would like to give everyone as much time as possible, but unfortunately, sometimes someone's going to have to go without getting the response they would like to go. And that has been Leo before. It's been all of us, I think. So this time, unfortunately, Ross, it's you. So we're going to go to David, and then we're going to hit up another super chat.
All right. First off, great job to all of you in the debate. I felt that it was pretty respectful. Paul, I think I recognize you from somewhere. Maybe we've had a chat before. But there is a question that I have for the Flat Earthers, and it's this question here. So in the Northern Hemisphere and the Southern Hemisphere, hurricanes rotate in a different direction. Can you guys explain why that is the case?
I missed that bit. You said something goes the opposite.
Oh, there was a screen share I forgot to show. Was there someone? Did someone have a quick screen share?
I did. Yeah,
I missed that entirely.
That was my question.
Oh, sorry about that. So while we're getting that, Ross, if you want to respond to David, that'd be great. And we'll pull up the screen share.
Can David just ask that question again, please?
Sure. So in the Northern Hemisphere and the Southern Hemisphere, hurricanes rotate in different directions. Do you guys have an explanation for that?
Yeah, absolutely.
Sure, go ahead.
Yeah, the word I missed was hurricanes. So yeah, absolutely, because if you've ever seen in the wake of a boat, if you've ever been in a speedboat, you will see that in that wake, vortices of water spiral away from it in opposite directions, because that's just the motion of the boat. The water doesn't care which hemisphere it's in or wherever it is. Those vortices will spiral in opposite directions because the force of the boat pushing through the water just causes, as part of fluid dynamics, they will rotate in opposite directions. So on the planet Earth that we live upon, the sun is the source of all light and resultant heat that comes from it. And so as it moves around the equator each day, taking 24 hours, the vortices in the air, which is sort of superheated in a sense from the reflected light that comes from the Earth, will do the same thing as the wake of a boat, and so they will spiral away in opposite directions. And some of these, using the so-called butterfly effect, will turn into supercells or superstorms as they suck up heat and moisture and energy, because the ocean is warmest around the equator. And so that is why they go opposite directions either side of the equator, because that's the path of the sun. Every now and then you will find one might cross the equator, but it's very short-lived because within 24 hours the sun comes back around again. The force of that sort of cancels that one out, so it doesn't become a superstorm. But if they spiral off away from the equator, that's how they turn into these supercells or superstorms, because of the amount of moisture they're drawing up out of the warmed-up ocean. And fluid dynamics means that once something is set in motion, it stays in motion, which is why we see water spiraling down a drain, for example. You can start it off in either direction, either side of the equator, and it will keep going that way because it was started that way. And so these storm cells are doing the exact same thing. And as a result of that, vortex energy tends to pick up on what's already in motion. So once you start something, more and more just wants to go that way. Fluid dynamics, it's as simple as that. So,
all right, so hold on.
Off the side of the equator, that's why they do that.
So guys, our next super chat is actually from Mr. Wilford, but Mr. Wilford,
hello.
After I read this, are you going to behave? Because I know you.
Yes, sir. Yes,
okay.
Sir.
Okay, because I run a PG-13 ship here.
Yeah, no, that's fine. Honestly, if you wanted, I could just re-ask the question.
You know what? I will ask it for you because you paid me to say it. And if I don't want to break the sacred bond.
I really just wanted to sit here, and because of how Leo reacted when I asked it in the debate, I wanted to see Leo's response to this thing in person.
Okay, so Mr. Wilford for $5 asked, "Can you guys talk about standard candles and the distance to stars? It's inconsistent with the idea of stars being 70 miles away." And I will go to Leo first. And so Leo, why don't you tell us about standard candles and how much they don't have to do with actual bits of wick and wax?
Oh, God. Sorry, that was funny. Thanks for that, Dapper.
You're welcome.
But yeah, so standard candles in astronomy and astrophysics and cosmology are objects that have a given luminosity that is, for all intents and purposes, constant in some sense or the other, and thereby, if we know what the luminosity of this object is and we know how far away it is, we can use that to gauge distances between us and other things as well. And that's why we call them standard candles, is they're a way of gauging distance in the universe. Cepheid variable stars are a really, really good example of this. These are stars that through a variety of mechanisms get brighter and then get dimmer, and then get brighter and then get dimmer. And we utilize these very, very frequently. Neutron stars are also utilized in certain respects as standard candles in cosmology as well.
Yeah. And I did want to ask another question to the flat earthers. If NASA and all these space agencies are lying, how many people would have to be involved in this conspiracy theory? And more importantly, why hasn't there been any major people to have spoken out against it? We know that conspiracy lasts very long. But I'll let you guys answer, and then after that, I am heading to bed.
All right, so here's what I'm going to do. I'm going to go ahead and, because I want to make sure we get to all the super chats by the end of all of this out there. They're coming in a little bit faster than we're getting to them. What I'm going to do is I'm going to say, Ross, I'm going to give you 3 minutes. Then whoever wants to respond, one person can respond for 3 minutes. And I'm going to give Ross the last word for another 3. And of course, if you want to, end earlier than 3, feel free. But Ross, here goes your 3 minutes. Go ahead.
Yeah, sure. I won't need 3 minutes. This is an easy one. It's called I can't even say the word now. Compartmentalization. Finally got it. Compartmentalization basically means the left hand never knows what the right hand is doing. Everyone believes they're doing their little bit for what is going on. There may be a few people at the top of it who are just having a big laugh at them all and saying, look at these goons. Yeah, at least we pay them heaps of money. They're quite happy with what they're doing. They don't have to know that the Earth is flat. They fully believe what they're doing, and what they're doing still works despite the Earth being flat and stationary. They can still send rockets up. They can still send satelloons up into the sky and have their geostationary satellites, but they don't really need to know one or another that the Earth isn't a spinning space ball. And I think that was basically it. Like, it was just about NASA, really, wasn't it? Like, somebody's having a big cover.
Well, okay, hold on.
So I guess
Dev,
if I could,
I will give you another 3 minutes, and then we will go. Oh, that's up to 3 minutes. You don't have to take the whole time, and then we'll go back to Flat Earth Fallacy Jesus. Then we will get in more super chats. So here we go.
So I guess to respond to that, how many people are actually involved in the conspiracy? How many people would actually need to know that the Earth is really flat and not round? Let's start from there.
But well, let's say how long is a piece of string question. I mean, it could be 5, it could be 500, it could be thousands. Like, who really knows? But as long as the vast majority of the people, the public who are falling for all this sort of stuff, the people who are, subjected to all the mass media, to all the entertainment, to all the bread and circuses that we all suffer from, to feel some sort of contentment with our meaningless existences. We're talking about a very tiny percentage of the population compared to about 99.9% of us. There are billions of us. There might be only thousands of them, and they're so far separated from us that it doesn't really matter then what we believe. We can argue this stuff back and forth all day, and they can still be quite content in their particular bubbles of existence because they're so far removed from us. So I think as long as they're still making a profit from us, they're still able to take tax dollars from us, then it doesn't really matter. Money is still ticking over and keeping people fed. The economy isn't really about who's at the top and why. It's all about, just so long as we keep on keeping the machine going.
What's gained from the lie, though? That's what I can't get. We've got this big conspiracy, this big lie. What is gained from it?
Profit.
And to respond real quick, what
kind of profit?
And if I could respond real quick, wouldn't it be an even bigger profit to completely overturn the established scientific theory and completely change science forever?
No, not at all, because that would share the wealth amongst all the people. Once we all keep the truth and we no longer accept all the lies, then why are we going to bow down to their authority? See, it's all about a game of authority. If they dangle a carrot in front of us, we'll go for the carrot. If they put a stick behind us, we'll still go for the carrot, but we'll do it for a bit of encouragement. But as soon as everybody's got all the carrots they need, we're going to lose the motivation to keeping their machine going, from which they make huge profits. If they can afford to put in $55 million a day into something like NASA to keep this going, then that means that the net result is they get way more back.
What is being kept going?
Okay, hold on. We've only got a few seconds left in what I allocated for this. So we're going to move on because we got to get through. Because, sorry, guys. Look, people are paying money for me to ask questions, and I will feel really bad if we don't get through all of them before we go off. So this next one is from Magellan for another 5 Singapore dollars. This is for, it says AJ, which I'm going to assume is Ross, I think. Is the point-to-point distance different on a curved surface compared to a flat surface? Yes. So it does make a difference for artillery. Now, it's not a question, but if you would like, I will give you another 3, up to 3 to respond. And I don't think we need to have a follow-up, so go ahead.
Okay, if you could just repeat that first part of it again.
Absolutely. So Magellan says, is the point-to-point distance different on a curved surface compared to a flat surface? Yes, so it does make a difference for artillery.
Okay, well, if the surface was curved, yes, it would, but the artillery itself is taking a curved trajectory. So if you were sending it over a curved surface, then you'd actually have to use even more velocity in the first place to get it to your target as you would across a flat surface. And the very first thing you learn in any sort of physics and engineering is that all calculations are based upon being on a flat, non-rotating Earth. It's not my words. This is the very first thing I was taught back when I was about 16, or not even 16, back in high school. When I started engineering studies, is that they said that all calculations in any engineering equation, and you can find it in multiple NASA publications as well, all of them take into consideration that we're moving above a stationary non-rotating flat surface. So when it comes to that trajectory question, fair enough, yeah, across a curved surface. And Magellan, you have to remember, he was back in the days where they were using compasses to navigate, and a compass will always follow that curved surface if they're going east to west, giving the illusion of being on a ball because it is a greater distance. So if you went on a straight line, which you might be able to do today with GPS, you wouldn't have to follow the curve. You could follow the straight line like airplanes do today.
All right. So our next super chat is a very quick one. This is for 5 beaver bucks from Covert Cuttlefish, who just says, "Here's your money." And by the way, beaver bucks are indeed what I call Canadian dollars, just like I call Australian dollars dollary-doos, because the fact that they're not called that is personally offensive to me. So our next one after that, though, is for $4.99 US from Vandali 1998, who says, "Do flat earthers believe in a geocentric system, or can you be a flat earther and think it's heliocentric?"
No. It's absolutely not heliocentric. Heliocentric basically saying the entire universe is going around the sun.
No.
Geocentrism says everything goes around above the Earth, but it is more Polaris-centered, if you will. But Polaris is the fixed point, the North Pole, and everything rotates around above that. So naturally then that makes it geocentric because it's all relative to the Earth. That's why all the constellations remain constant for as long as they do and have and always will.
I'm not trying to speak here very much, but I will say that under the heliocentric model, while the Earth does go around the sun does orbit around the black hole in the center of the galaxy, and that black hole is pretty much immovable relative to us, so it does not go around us.
Also, let's all cheers for Sagittarius A star. If you play Elite Dangerous, go there at least once. It's worth the trip.
It is a really fun thing in that game, yeah.
Yep, it is. Although, if you're going from the bubble in Elite Dangerous, do not expect to get a whole lot of exploration money, because a lot of the star systems between here and there have been explored, so you've been warned. All right. So for $10, Sigma Any, and I hope I'm pronouncing that right, says for Bev and Ross, although only Ross is here, to show immense lack. Let me make sure I get this right. To show immense lack of understanding of measurement technologies, and then to tell me, a spatial scientist and land surveyor, that I don't know what I'm doing is simply baffling. So Ross, do you have a response for Sigma Any, who claims to be a spatial scientist and land surveyor?
Yes, unfortunately, he takes upon what he sees as some sort of like gospel of reality, if you will. Whereas here on the flat Earth, we understand this thing called perspective. It means when something gets further away from us, it appears to get smaller, but so too does the space between us and that thing. And so he's using like the visual measurement, say through an optical instrument, and assuming then that he can make an accurate distance calculation. And I think that was the problem we were having in the pre-discussion too of the debate, is that he's trying to say that you can make accurate measurements using a single optical observation, and you simply cannot, because, as I say, if you've already known the distance, which you have to measure physically, say with a measuring wheel or an odometer or something physical, which can give you the exact distance to it, then you can overcome the limitations of the visual observation, which says that a lot more space or distance exists in a lot less visual distance the further away it gets. So yeah, his observations might be quite accurate for short distances. And when you put a lot of short distances together, you can get an accurate measurement of larger distances. But when you try and use a single observation of a large distance, you won't really get.
And that was my timer going off. So does anyone here have? So I'll let us go for a response, and then we'll let Ross have the final word. So Paul, you had a response there. Go ahead.
Yeah. What I was going to say, if we lived on a flat plane. If I'm stood on that flat plane, so we can have 0 degrees above my head, so that's 0 degrees. From my feet going out forward to me is 90 degrees. Anything that is above that horizon will never get below 90 degrees, no matter how far away it goes. So it will never disappear behind a curve. That has got to be absolutely impossible. So 90 degrees from my feet, anything above that 90-degree line, no matter how far away it goes, it will never disappear because it cannot possibly go below 90 degrees.
All right.
Okay, well, that sounds very... Yeah, I'll just jump straight in.
Yeah.
That sounds like a very logical observation, and technically you are correct. It is 90 degrees to your feet. But visually, it's a completely different thing. And I made a video quickly before the debate started today, which I put on my channel to show exactly how that works. Using this very brick wall that's behind me, is that perspective means that there's only one horizontal line, and the horizontal line is actually always the one at your eyes or the camera level. Everything else is converging upwards towards it or downwards towards it, depending on the height of your place of observation. So even though you are technically correct, the 90 degrees is at your feet, visually, perspective means it rises up to your eye level and creates a convergence point at that spot. And of course, distance diminution then means everything appears to get smaller and smaller in the distance, so it will shrink and disappear from you into that singular point which we can no longer resolve into something visual anymore, unless it's a really big object, in which case the bottom of it will be obscured by that convergence point, and you can still see the top of it with a good enough zoom to zoom in into it. So the right angle exists at your eyes. That is what horizontal means. That is where the right angle truly is in a visual sense. In a physical sense, absolutely it's at your feet, but that right angle from your feet converges to a singular point, making a triangular point of view, which is basic perspective.
All right, well, with that, what we are going to do real quick is we are going to take a quick intermission for a word from our sponsor, which is me. You're going to hear a word from me, while I also do things like, you know, actually, we're going to let Brenda in real quick. So, Brenda, hello, but I'm just giving everyone the heads up. We're going to be taking a quick intermission. We will start off with your impressions about the show. And then once you give your impressions, we will go on to the next super chat, and then we'll take it from there. But first, it is time for a quick intermission and a word from our sponsor, which is basically my Patreon and merch store. Feel free to do any of those things that you want, and also hit like, because we have way more people watching than we have likes. So here we go with the intermission.
I want to take a moment to talk about something serious. There is a problem facing late surviving non-avian dinosaurs in modern America. Hunting is very strictly regulated, and only allowed at certain times of the year. This means that for much of the year we have to rely on farm-raised food, which means money. If you want to help a starving dinosaur, please consider donating on Patreon, or buying from my merch store. Links are in the description. Please help. Dinosaurs all over YouTube are depending on you to help them through the hunting off-season.
Nani? Dare? Oh, Kojira desu ka? Hai, Kojira-san. Hai. And sorry about accidentally replaying part of the intro video. I forgot to turn it off, but that's okay. We are back, and we are going to start off with Brenda, who just joined. And Brenda is, in fact, the person who ended up being the trigger for Right the Hand being hidden on the channel. So you're already infamous, Brenda. Welcome.
Well, yeah, I've had some pretty confrontations, pretty sparked confrontations with him. This is something about flat earthers. They tend to be extremely reactionary and religious fundamentalists. But I thought the debate was one of the better flat Earth debates on modern day debate. Sometimes I felt like people who were debating on the globe side were not really very familiar with the arguments the flat earthers bring up, and in this case, both all of the globers did a great job, and so it was very good.
Well, thank you. Now, like I had said before, we are going to go to a super chat, but I also want to say to the super chatters, thank you very much. You guys have almost paid for my groceries. So when I eat that daikon radish I just bought today, you guys have paid.
Well, brother.
I know, right? But no, I really do want to say thank you, because I recognize that literally no one is under any obligation to show up and do anything to help this channel. So the fact that anyone does really means a lot to me. So we have 4 $5 dues from Virillion, although I haven't heard someone else in the chat calls them didgeridollars, which I also like, but I'm going to stick with dollary dues. But we have Ross. Why do compasses have to be weighted differently for North and Southern Hemisphere? Which, that is an interesting thing. That is the case. If you get a Southern Hemisphere compass, it will not work in the Northern Hemisphere.
That's absolutely not true at all. All compasses work exactly the same because they're equally balanced on either side of them. And anybody that thinks that, they're a gullible fool who pays too much money for a gimmick that they don't
so
need.
Have you
just
bought...
not true. It's just factually wrong. It's wrong.
So Ross, have you brought a compass that you purchased for one hemisphere into another?
No, it's not necessary. You can just take a needle and magnetize it against your shirt or something. Or something metal and strike it and just float it on a leaf, and it's still going to work as a compass no matter where you are. It doesn't need to be hemisphere specific. So
this is something that I touched on it a bit in the debate, and it's still really bugging me. And it's that so there's a lot of really easy things, or at least feasible things, that flat earthers could do, where there's a prediction that the flat earth would make, and it runs contrary to the globe earth, but I don't see the flat earthers actually getting off their butts and doing it. Why is that?
Well, because we don't need to, because we have logic and critical thinking, and we don't fall for hocus pocus claims in the first place. Like, no compass should really work at all anyway, until you're almost level with the poles, because otherwise they're pointing down through the Earth towards the pole through this massive curvature. But that's never the case either. So how would a compass
sad.
even work by holding it flat and level?
Yeah,
So,
that
go ahead,
isn't
Brendan.
that isn't how magnetism works. That isn't how the Earth's magnetic poles work. I mean, it just isn't how it works.
But they still have to be weighted either side of the equator to work.
Yes, they do. You actually do. You can, in fact, buy compasses designed to work in the global south or north, and they are weighted differently because if you take a northern hemisphere compass into the south, it will drag along the bottom, and if you take a southern hemisphere compass into the top, it will start to drag along the top, which will make it inaccurate. It's not that it won't work at all. It will still tend towards aligning itself with magnetic north, but it will be inaccurate because of the additional friction because it is not balanced.
Cool story, bro.
I mean,
in line with your question, Dapper Don, I could ask Aussie Jesus. Recently, we had a solstice, an equinox.
Equinox, yes.
Yes. And did you perform any experiments to test, to test the equinox and to explain it for a flat Earth model?
No, I don't need to do experiments to test thousands of years observations of reality of the sun, because I understand how the model works on the flat stationary Earth, and it's simply because the sun,
An
the sun is
equinox
on
is
its annual path.
Hey, we're gonna leave it with Ross's word there. We're gonna.
Well, I haven't finished.
Okay, well, Ross, if you can finish in the next, just take a little bit, and then we're going to go on to another super chat. We're close to finishing up the super chats, so then we can go into a more free-form discussion for the next
Hey, Dapper, once the super chats are done, can I ask a question of a friend of mine who did not have the money for a super chat?
Yes.
Like once they're done.
That can be the next thing we do after the next
No
super
worries.
chat.
So as I'm trying to describe on the flat Earth model, is that the sun still takes the same path every day, which is around the equator, but now that it's on the part of the annual ascent until it gets to June 22nd when it peaks at the highest point, well, twice a year it passes through the equally distant point, which is the equinox, which means it looks as though it goes exactly around the equator, which is why at midday, anywhere on the equator, it won't cast any shadow whatsoever, but it doesn't mean it won't cast shadows anywhere else that's at a different latitude from the equator. It only happens at that particular spot. But that is exactly the predictive expectations of what we see on the flat Earth model. If you understand, the sun is actually getting higher, but the apparition, the hotspot apparition that I was talking about on the actual firmament, remains the same height the whole time. So that's why the sun itself doesn't get smaller, but the path it seems to take gets smaller until it reaches the Tropic of Cancer, where it peaks and then starts descending again. And then at the next equinox, hits the equal point. That's why on the analemma, those two crossover points are the two equinoxes, and why the larger part of the figure 8 of the analemma is when the sun's in the south, in our summer, on the south side, because it's closer to us. So something closer appears bigger and further away appears smaller. But both sides of that analemma are actually the exact same size. It's just in appearance to us, the bottom side appears bigger because it's closer.
All right, and for $4.99 in US dollars, we have from Vandali 1998. So how do you know the sun is circling the Earth and not the other way around? Any reason to think so? And I believe that is probably for Ross. So what we're going to do is we're going to give Ross a chance. We're going to give another person a chance, and then we're going to get Ross's final word on that. And then we can be a little bit more freeform because we are at that point caught up, I think. So here you go, Ross.
Yep, no worries. Well, that is basically the question that brought about the theory of relative motion, is because relative to one another, you cannot tell the difference. Any scientist will tell you that. Every scientist who's really studied the matter will tell you that, is that we cannot tell you any differently whether it is we who are moving through the universe or the universe moving around above us. The thing is, though, we can do like seismic type tests or whatever to detect motion of the Earth. And
we got a question about seismic one super chat.
Famously admitted that there is no optical experiment that can be done to detect any motion of the Earth. So basically what that revolves down to is that the sun is revolving around above us. And the very proof that nails that home very quickly is that the sun appears more or less overhead at midday everywhere at midday, give or take a bit of time zone fluctuation and whatnot. But if we were the ones going around the sun, as the heliocentric model insists upon, then our clocks would have to be adjusted by about 4 minutes per day to keep the sun overhead at midday. But we use a clock of a fixed exact amount. Now, it doesn't matter if it's 24 hours or 23 hours, 56 minutes, whatever you want to call it, doesn't matter. But that amount is fixed, and we call it 24 hours. And it's fixed every single day. So if we're going 24 hours every single day, that means every 6 months, the opposite side of the ball would be facing the sun if we were going around above it. But if the sun going around above us on a fixed circular motion, then 24 hours works perfectly.
All right, and so let's get one person who would like to address this. And if no one, we'll just move on.
Yeah, well, I'm going to have to jump out because it is now...
Oh, is it like 6 a.m.?
5:10 in the morning.
Oh, my goodness. Paul, get yourself some sleep, my friend.
I will do.
All right, well, thank you very much. It was a pleasure, and it was nice meeting you, man.
You're a gentleman, Paul.
Nice meeting you. I've met Leo plenty of times before, but yeah, thanks for jumping in because you made my job easy because you two just took over it. Brilliant.
Well, don't let us talk over you if that's what happened.
No. You knew far more than I did.
All right, well, thank you. You have a wonderful weekend because now it's Saturday morning for you, huh?
Yeah, it is, yeah.
All right, well...
And Ross, nice meeting you as well. We disagree, but we disagree on one thing, that's it, so...
But we agreed to disagree, and that's fine.
We'll agree to disagree, yeah. A pleasure meeting you anyway. It was a good night.
Okay.
Take it easy, Paul.
All right, so later. And we are going to go to Mr. Wilford's question, and then we do have a super chat, but we're going to get to Mr. Wilford's question, we're going to get to Mr. Wilford's question first, and so we're going to do the same kind of deal where we're trying to catch up with the super chats, but go ahead and ask that question.
It's not my question, it's actually Order 343's question. I just asked it for him. Yeah, Orge, whatever his name is. He said, question for Ross, do you know of an explanation for seismic waves on an FE and the behavior of PS and surface waves on seismographs? And essentially what he's asking is we can do seismic imaging on the interior of the Earth, and we can watch different seismic waves kind of bounce around off the crust, and it's a pretty good indicator the Earth is spherical. Because it doesn't make sense if it's flat that we get the readings we do, like as geologists. And so he wants to know what's the flat Earth explanation for that. Why?
Okay, well, I'm certainly no expert in such matters, like I'm not a
right. No.
Let him go.
And I can't be a complete expert in just about everything to do with geophysics of the Earth and whatnot, but I can probably give you a reasonable logical deduction. And to my point of view is, well, if everything is sort of floating above sea level, like we have an iceberg, most of it is below the water level, but you got the tiny little bit above it. Well, what about landbergs? Maybe that's what continents are. Maybe they're fixed on pillars, as some people suggest, or maybe there's big floating landbergs that sometimes bump and grind into one another. And because the whole substance of what they're sitting in is still fluid, then maybe you're just measuring those fluid waves, and these seismic detectors, which are very sensitive sort of things, that's what they're detecting. And it's just a matter of interpreting it the right way. Like if you assume it's a ball in the first place, then you're going to find a way to make it match your expectations. But if you think of it differently and then you try and interpret it in another way, then maybe it will match that. That's my answer.
Okay. And I do want to say, Ross, on my PG-13 streams, you can't say bump and grind too much, man.
Sorry.
I'm just kidding. It's fine. All right. Would anyone like to respond to that? All right. I'll take that as a no. All right.
To respond to it, the PNS waves are I've got a lot of noise here. I'm sorry.
It's okay. We can deal with it.
Yeah, I never know what the fuck's going on around here.
That was our first F-bomb. That's it. We're done for the stream. PG-13.
Sorry. PNS waves are some travel faster than others and slower than others, and the fact that there is a shadow that can be cast when you have an earthquake, it that sound, and the waves radiate out, and the core of the Earth casts a shadow on the opposite side of the Earth, and that indicates that there is, in fact, a core there. Otherwise, if it conducted the P&S waves, then there would be no shadow. And in fact, it's like an ultrasound. Like when you go to who's pregnant goes to a doctor, she has an ultrasound, and you can map the baby with the ultrasound. We can map the core, the inner part of the Earth, with the sound waves that are produced by earthquakes.
So you go all the way through the Earth, but only the core creates a shadow.
The core creates a shadow because it is a very compact, very solid core that is different than the other layers, and therefore it doesn't conduct, it doesn't transmit the sound waves from earthquakes. Therefore, it casts basically an acoustic shadow. That's basically how it works. And you could
look. Take your word on that, because it sounds illogical to me. Like, if you can go through the entire Earth, but the core, which is allegedly molten, sound travels even better underwater. So
I want to point out that there's the outer core. Real quick, I just want to point out that this geology says that there are two parts to the core. There is a liquid outer core and a solid inner core. So the solid inner core is what's going to block these waves.
Yes.
Okay. Well, that sounds feasible if that's what you believe, and you think that sound waves can prove that. So do they get like louder in the liquid part before getting shattered by the solid part, or like, is it liquid all the way through to there, but the crust is solid but still passes through the solid?
Well, there's different layers. There's different layers.
It's about propagation. How are these waves going to propagate through different mediums? They will move at different speeds through different mediums, and from that we can derive what the mediums are constructed of.
Well, I'll have to take your word on that, because I've never seen it.
All right, well, we'll move on to our next super chat. Before that, I want to acknowledge a super sticker which came through from Silver Harlow, which seems to be a smiling fox. And of the mammals out there, I like canids pretty much. They're pretty good. Although, to be fair, one of my favorite canids is the maned wolf, which is not a fox or a wolf. So, Ross,
what does the fox say? Again?
Oh, that is a good question. Ross, do you know what a maned wolf is?
No, I haven't heard of that one.
All right,
I do.
Here's something that I recommend after this, and this isn't to do with anything like flat Earth or controversy or anything. Just Google maned, like M-A-N-E-D, wolf.
Yeah.
Really cool animals from South America. Check them out.
The longest-legged canine.
They look like red wolves on stilts, and it's amazing. But
are they part of the canine family? Are
they? They are. Yes. They are some of the coolest canines out there. So check those out. But Marv the Martian for $4 says, "What force keeps the sun in its path on the flat Earth?" Which is a question I would also like to know the answer to. So,
I would also love to know the answer to that question. But from what I can gather, is that the North Pole, as we know, is the place where all magnetic compasses point towards. And since all the stars, the sun and the moon all rotate around that particular point, we have to there's some sort of electromagnetic force or something going on that causes that to happen. But what that force is probably forever going to remain a mystery, because we can't even get as high as the moon unless you believe Hollywood fantasies.
I know what it is.
Let's make sure that Ross gets to finish. Are you finished, Ross?
Yeah. No, I'm still trying to say that that it's coincidental, so far as I'm concerned, that the point where Polaris disappears from view on the surface of the Earth also happens to be the path which I personally believe, and pretty sure, is what the sun itself takes. But the sun itself is above the firmament, much higher above the firmament, and it's pretty much on something akin to a Tesla coil. As it spirals around, it changes its height by a degree per day, almost a degree, which is
Can we measure that?
2.25 of them a day. Well, that's how we measure a day, and a year is how long it takes to reach the solstice, our winter solstice, your summer solstice. That's the peak of it, June 22nd, and then it spirals back down, is pretty much how the sun works. And I just figure it's a little bit like, where did the ancients come up with this idea of doing that pole dance type thing? Not the type you're thinking of. I'm talking about PG-13 one, where everybody has a ribbon
like a Mayday pole, like the maypole.
The maypole, that's the one. Yeah, there you go. So it's something a little bit like that. That's where the tradition came from, is because they understood the celestials go around the central pole, and they wrap in, they unwrap, they wrap in, they unwrap.
All right. So I want to jump in real quick and say one short thing, which is the magnetic North Pole does not line up with the geographic North Pole. If you were at the North Pole, your compass will point towards a spot, which I believe is currently somewhere in northern Russia.
But wouldn't that be relevant to the actual position of the sun? If the sun's path is actually somewhat elliptical, then would not that cause the so-called wobble or position of the actual magnetic North Pole, like this geometric one or geometric one?
No, and here's why. Here's why. The current position of the magnetic North Pole is changing as history goes. Historically, it has been in many different places. It is kind of wobbling around. The sun has not been affected by that wander in the location of the magnetic North Pole that we have recorded throughout history as changing. So if you want to say that the apparent location of the sun depends on the magnetic North Pole, it would have to change throughout history in a way that correlates with the known changing location of the magnetic North Pole. It has not done so.
Yeah. Well, you don't know that. Nobody tests.
No, we have thousands of years of astronomy.
Look, sun go down.
Ross, this is the kind of thing that I said at the beginning we weren't going to accept. We have thousands of years of careful astronomy, and the reason we have it is because people needed to know things like when to plant their crops, when to harvest, and things like that. People lived and died for like 5,000 years based on where the sun was on particular days.
But it's also based on a very primitive understanding of it. It's not based on
great, but we have records. We have records of where the sun is.
Hey, Dapper,
for thousands of years.
That's a good point for me to decide to get out of here and go to bed.
All right.
Orgave343 may want to join in and ask some geology stuff. So if you guys can talk to him and get him a link, I would recommend you do so.
All right. Do you have his contact? Because I
think Leo might. I don't.
I don't have his email.
All right.
He can probably give it to you in live chat, but I know that's kind of sus. So
yeah. So try to hit me up on Twitter or something, Orge.
I'll see what I can do.
All right. Yeah. On my end as well. Thank you. But no so, all right. You know, we're just gonna go on to another super chat because we had one.
I just would really like to ask a really quick question, if you don't mind.
Oh, absolutely, because you haven't asked a question for a while, so go ahead.
You've talked about the geometric or geophysical North Pole as opposed to the magnetic North Pole. Mm-hmm. And all I'm saying is that maybe this geometric North Pole that you talk about, or actual North Pole, maybe that was just figured out at one particular time when they were doing the charts to the actual physical magnetic North Pole, but it got accepted as the standard. But then as the magnetic pole drifted, the standard didn't change with it, the maps, whereas the reality in the real world that we live upon, maybe the real North Pole and the geometric North Pole are still the same thing. It just doesn't reflect upon the ancient traditional maps that we used back in the day when it was their particular time of using the geometric North Pole.
An interesting thing about the magnetic North Pole is that currently, while we've been measuring it in modern times, which is the first time we've been able to super accurately measure it, because right now we know really right where it is. That's not been the case for most of history. But since we've been able to very accurately measure it in the last few decades, its rate of change in location has actually been accelerating. But that is not at all correlated with any change in the apparent location of the sun, that, like, at all, right? So in the past few decades, the magnetic North Pole has been zooming around all over the place. It was different when I was born. Well, okay, when I was born, it was 150 million years ago, so whatever. But when Leo was born, it was in a significantly different place than it is now, and it's gone all over the place since then.
Excuse me. Leo was not born. He was decanted.
Oh, yes, I forgot. The tot is in the pot.
No, not funny. Leo, come on.
Come on, Leo.
No, I'm saying
Brave,
like you're
New World.
You're correct. What are you talking about?
Oh, okay, there you go.
It's correct.
So, you know what? I appreciate that. That is another... Look, I like nice references. Like, I liked Caleb Dark reference to the Forgotten Chaos God Malice. I like the Brave New World reference. Actually, that was a book I was supposed to read in high school over summer vacation, and then I didn't, but I barely passed the test by just going with the most interesting answers on the multiple choice test. So...
Wow.
Yeah. But, yeah, so... The problem we have with the magnetic North Pole is that we are watching it right now move. We can measure where it is, and we can measure how fast it's moving, where it's moving to, and there is no corresponding change in the analemma or the apparent location of the sun anywhere in the world. So if you want to say that the position of the sun in some way, or the apparent position of the sun, I suppose, in some way depends on the location of the magnetic North Pole, you have to account for the fact that it has not changed, despite the fact that the location of the magnetic North Pole has changed dramatically over just the past few decades.
Okay, well, yeah, I was just curious because a lot of people say that Polaris also itself wobbles or isn't exactly
the
center of the pole.
I believe it's about what half.
I'm just suggesting that the sun is also moving in relation to that, but who was actually really measured and checked? I don't know.
Quite a few thousand people throughout history have, actually.
Yeah, but you can generalize and make that sort of claim, and once again, and I'd have to ask for some specific names and publications and so forth, and all of nearly everything when it comes down to the globe is just says, oh, well, thousands of people have done it. We've got thousands of pictures of Earth and space, when it turns out you've got zero. It's all of these generalized claims end up being totally exposed as lies.
Are we in sort of general discussion now, or are you still doing
not quite,
because
we keep getting super chats, so that's one of the problems. So I do want to say, so the Polaris does in fact not sit directly on the celestial North Pole. It's about a half a degree. It's a little bit less than a half a degree away. So if you zoom in on it with like a really good telescope or something, and you do like a star trail, you will actually see that Polaris does make a small little circle. It's not quite on the North Pole, but it's close. It's close enough that if you're doing like line of sight with, like manually, you're sighting through a, now I can't remember the name because I'm tired. What am I thinking of, guys?
Like the ancient navigators used for thousands of years.
Yeah, I can't think. For some reason, like you know how it is. Sometimes you just can't come up with the word. Sextant. There you go. That's the word. So if you're sighting it with a sextant, it's close enough to the North Pole that it doesn't matter much. But yeah, it's not quite on. We do have a question for $5 from Silver Harlow, who says, "Will there still be flat Earth believers once we have affordable space tourism? Probably next century." So there's a couple things. One. Look, affordable space tourism is like fusion power. It's always just a couple decades away. It's like it's with one of the things. Those things.
I got a response.
One of the memes I love sharing on Facebook is a picture of an article in a newspaper dated 1978. I think it was dated 1971. Sorry, when they were going to the moon, and they said that by 1978 we will have bases on the moon. And so this has always been the thing with space. It's always been this in the foreseeable future, this dream they keep selling us. They keep telling us, and then a few years later they say, oh, in another 20 years we'll be able to go back to the moon, we'll be able to go to Mars. It's always this future dream that they keep selling us, but none of it.
We just went back to Mars.
That doesn't prove we didn't go to the moon. So yeah. I have a response to what was the question again, please? Could you say the question again?
Yes. Will there still be flat earthers once we have affordable space tourism? Parentheses, probably next century.
My prediction is 1 generation after we have colonies on Mars, there will be people who believe that Mars is flat.
I don't think we'll ever have colonies on Mars.
Well, it's a good joke. That's all.
It is a good joke.
Funny. But that's what it is, you know. All of it is just humour. It's entertainment. We cannot go beyond low Earth orbit. There's nowhere to go.
Yes, we can.
There's nothing out there. You're looking at lights in the sky.
If we just
not land on them, we would never go to space.
Ross, you just say things, but you have to back them up. You have to back up the things you say. So you can't just say things. That doesn't mean anything.
Well, I can just say things because it's based on the experience of many, many years of research to say that space is a load of bullshit.
Wait, hold on.
Hold on. We will never go to space.
So this is based on years of experience of you trying to get to the moon?
No, I know we can't get to the moon.
Okay, so it's based on years of experience of what?
Study of all the data.
Okay, well, all the data includes all the data of things like retroreflectors that were placed on the moon. So I'm assuming that you have tried to find the retroreflectors, right?
What about all the lost telemetry data? Where did that go?
Okay, well, that's great. But I'm going to assume that you... So when you aimed a laser to test the distance to the moon at a retroreflector, did you actually get a signal back?
There is no such thing as a retroreflector.
So you haven't tried that experiment then?
I haven't, but have you?
Okay, well, no, but you just said that you had been spending years trying to figure this out. So I haven't.
Yeah, I'll be honest. The data. Studying the data is different.
The data includes the actual experiments of people shooting lasers at retroreflectors on the moon and getting signals back. So the fact that you neither accept those nor have you tried to debunk them yourself means you haven't studied the data. What you've actually been doing, hold on. What you've actually been doing is just being incredulous, which, hey, great for you. That's be as incredulous as you want. I don't really care, but you cannot lie to me and say you've looked into it if you have not either accepted the data that other people have gathered or debunked it, or at least find someone who has. Have you found anyone who has actually done the retroreflector experiment?
Is different. Accepting the data is taking it on faith, but debunking it or negating it.
You haven't tried that.
I don't think the evidence is good enough. Now,
no. Hold on. No, we're not going to let that go because that is the genetic fallacy that we said we weren't going to allow. If it's published in the peer-reviewed literature, it is currently the data that we have. If you want to debunk it, that's fine. But you have to go get out there, get off your butt, and actually do the work. You haven't. So do not tell me that you've studied this, because if you had, you would either be accepting the universal consensus of everyone who's tried that the retroreflectors are there, or you would have your own measurements of their absence. You have not that. So you have not studied this in a way that actually matters for this question. I am going to go on to the next super chat. I am going to go on to the next super chat. Here is the next super chat. This is from Vandalia 1998 for $1.99. Dapper, were you born or hatched? I was hatched because I'm a Ceratosaurus, and that is how Ceratosauruses all worked. Dinosaurs all come from eggs. So there you go. That was quick.
Wait, is that true? I thought some are live birth.
I have yet to find any live birth dinosaur. So here's the big thing with dinosaurs, right? So dinosaurs have highly calcified eggs. I know we're going pretty far off topic here, but we actually have dinosaur eggs from a wide range of dinosaur taxa. And they, sorry, what was that, Ross?
I think I've had enough of this shit show. If you're going to mute me when I'm trying to make an actual point on the topic, and then you guys start talking about dinosaurs,
I'm answering your question. Ross, I'm going to let you know I have been extremely generous in making sure that you have enough time. But when I started out the stream, I said that we were not going to engage in the genetic fallacy, and then you did. And so for that reason, I stopped you from continuing to do it, because it was one of the few rules that I set out. I set out very few rules for this stream. One of them was we're going to keep it PG-13.
You're the one making the positive claim. So you're the one that has to create the positive evidence, not me.
Ross, we already have reams of positive evidence. Students in undergrad and graduate programs all over the world do retroreflector experiments to measure the distance of the moon. If you want to contest it, provide your own experiment or an experiment from someone else that contradicts them. You haven't done that.
What I was going to say in response to that, mate, before you muted me and move on to another topic, is it's the same argument I've had in many of these atheistic debates, where the people who say that if you believe in a God, then it's up to you to provide positive evidence. It's not up to them to provide negative evidence for the claim. And this is what we're basically boiling down to, is that you're the one making the positive claim. How can I disprove a negative? It's just not up to me.
But you're also making a positive claim.
Yep, you're there's
I'm making a negative claim.
There's a possible.
By the way, can I explain the animation that I'm sharing really quickly?
You know what? No, we're going to move on to the next super chat after I finish with explaining that we have a wide range of dinosaur eggs preserved from a wide range of taxa. All of them have hard shells. Therefore, we have good reason to think all dinosaurs laid hard-shelled eggs. That's where we're going to leave it. Then we're going to go on to Vandalia 1998. I can't even read anymore. He says for $4.99, will Martian creationists say if we came from Earthlians, why are there still Earthlians? I expect yes. And then after we get any comment that we want from that, we can go on to this diagram. Does anyone want to comment on the Martian creationists?
No.
Okay. Now, Leo, you may in fact explain what you are showing.
Yeah, this is a time lapse of the precession of Earth about its axis. It will precess once every 26,000 years, roughly. So Polaris is not always in the same position, as you can see from this time lapse graph. It just depends on where the Earth is at in its precession, because it precesses about its axis. We've measured this numerous times in numerous different ways.
Yep, and in fact, during historical times, we've gone from Thuban to Polaris as being the pole star.
Mm-hmm.
So we've done a small part of this during the time in which humans were actually recording their astronomical observations.
Yep.
More claims without evidence.
No, these are just literally recorded as the actual astronomical recordings of people doing the astronomy. And let me remind you, not just because it was fun, but to make sure they didn't die. These were life or death measurements for these people. If they got them wrong, people could starve to death.
Yeah. Often just a little bit, and you miss your mark by God knows how many miles, and yeah, you're screwed.
Therefore, your crops fail.
Crops. Crops failing
you follow
happen.
The seasons, you follow the moon cycles, and you know when spring occurs, and you start planting your next crop in that spring. It's very simple stuff.
But that's the thing. Before we had careful astronomy about this, famines were more common because people were less able to reliably depend on when to plant. There's a reason that we have put, in the history of the human race since the agricultural revolution, so much emphasis on knowing exactly when the right time to do things like plant and harvest is. It's because if you screw it up, even by a few days, and it's easy to do if all you're doing is like making scratch marks in a wall, it's easy to screw up. And when you screw it up, that could mean the difference between, your family surviving into the next year and you having to eat the youngest kid because he's the weakest.
Eat the biggest one, and he's got more meat on him.
Well, I mean, maybe that one too. But I don't want to get too far into the weeds, into the economics of cannibalism. But that's the thing. People were making these observations not because it was fun, not because they were just curious about the sky, which, I mean, they were. But these observations and these buildings to help them make solar observations and things like this was a life and death matter for people. It really mattered, and they had to get it as accurately measured as possible. And we still have ancient manuscripts with records about things like what star was the North Star, what days did certain things occur on, where the sun was at certain places at certain times of year. Now, granted, Some of them can be a little bit tricky to date here and there because we don't have the greatest chronology for the ancient world, especially in the Bronze Age. But still, even if we...
I really do. I think you're reaching. You're just making assumptions and assuming this stuff is correct. And I'm not saying that you are 100% wrong, because some of this stuff does exist. But
so were the ancient Egyptians just pretending that they were measuring the sun in order to inform them about crop management?
No, not at all. But they also measured the river levels, because they depended upon the annual floods, which came down from Ethiopia. So they did measure the flood levels. The water level was far more important than.
But the thing is, you can't predict when to plant based on last year's measurement of how high the water was. Because the water level changed.
You're observing the water levels.
But that's the thing. No, it's not. Yeah. It's the water level tells you where you should plant. The stars tell you when.
They planted on the flooded plains, where a lot of silt got depleted.
Right, that's where. That is where. So when the Nile floods and it brings fertile silt up, right, you use previous flood levels to tell you where you're likely to actually be covered by silt so you can plant in those areas. But if you want to know what day to start planting, last year's flood levels aren't going to help you. You need to know what day of the year it is. In order to know what day of the year it is reliably, especially since the length of the solar year doesn't exactly line up with the length of the day, you need to, in order to make it reliable, you need careful observations of where the sun is in the sky in relation to the background stars.
Crops aren't that specific to really give a shit about what day of the year it is. You don't have to always do it on.
That's not true. That's not true.
Yeah, that's even modern farmers frequently.
February 27th and probably still get the same results.
But that's just not the case, though. Even modern farmers frequently know to the day which day they should be planting or sowing.
But that's mainly because they make moon observations, and the lunar observations are dramatically different from any other observation.
Because the moon does not tell you what the climate is going to be over the next few months, because the moon doesn't sync up with the solar year.
Whether it's going to be
in fact, that's one of the other reasons. That's one of the other reasons it was so important.
That's how Easter is worked out.
No,
Easter is worked out.
Hold on.
Post a full moon towards the spring equinox.
I'm sorry. Are you saying that if you plant on a waxing moon, you're going to have a more fertile harvest? Is that just what I heard?
Well, not necessarily just waxing. It also has to be in a fertile sign. Like if you don't know what sign it's in, it could be in an infertile sign, and you'll get far less good result as if you did it in a fertile sign.
So we're doing crop astrology.
Everything is based on astrology. Yeah, that's right. That's what you're actually talking about. You're talking about astrology.
Okay, well,
you're saying that's how they determine what season to plant in, and that is astrology.
Ross, you would have starved. You would have starved because astrology wouldn't work to help you plant crops.
But this is exactly what we're talking about. You were talking about astrology.
We're talking about astronomy, not astrology.
Yeah, but astronomy is astrology. If you follow its roots.
It's
not.
Look.
Astrology is the sign means the constellation that it's in.
Ross, I will give you this.
The constellation that the sun is in, it tells you what season it's in.
The first people who were making
Leo, then we're going into winter.
The first people who were making careful observations about the sun did not draw a line between astronomy and astrology. I will give you that. However, if you're going to claim things like which part of the zodiac the moon is in is going to measurably affect crop yield, I'm going to want a source.
That's what farmers use to this day. That's what I've been using for the last 25 years.
Well, I'm glad that you're not a subsistence farmer.
No, well, I'm not a farmer. I'll grant you that. I haven't got there yet, but I'm on my way to getting there. Well, but I've always been using it for my backyard purposes and for the purposes of when to know to mow.
I'll just say this. For your own sake, please do not become a subsistence farmer.
Oh, I'm on my way to getting there.
Well,
this has been my life goal.
Please at least make it so that you continue to be able to get supplemental food from the general supermarkets if you need to. Because quite frankly, Ross, based on this conversation, I worry for your safety if you were to try to live entirely off of your own crops.
You were trying to say that what these people did for survival, which I know down to a scientific art, makes me wrong, where I'm just reinforcing the things that you were saying.
Because I'm saying that they needed to know what time of the year it was, and you're saying that if the moon was waxing in the constellation of Capricorn, that means something for their crops. One of those things is true. Well, the other one is complete and utter nonsense. And I will leave it to the audience to figure out which one it is.
Next time, because that's when spring is for you guys. It's actually our autumn down here, but, you know.
It is your
the seasons are reversed. The sun, the sign that the sun is in at the time determines the seasons. That's
Wait, you said okay. The sun, yes, but you had said the moon. Did you misspeak?
Yeah. No, because the moon also determines the time of the season to plant. That is why, as I was saying, that's how Easter has always worked out as the spring celebration of new life, is because the spring equinox for you guys is celebrated on the Sunday closest to the full moon, closest to the equinox.
Okay, Ross, there are two dates for Easter. How are each of them calculated? I'm curious.
No, there are multiple dates. It's different every year, and it's calculated as I was
every year. Two dates are selected for Easter, one by one group of Christians, the other by another group. How is each one calculated?
Oh, I wouldn't know about that. All I'm saying is that the way it is calculated is that it is the Sunday closest to the full moon, which occurs closest to the spring equinox.
But are you aware that that is because it attempts to sync, that the Christians attempted to sync their calculations for Easter not to harvest festivals, but to the Passover festival in the Jewish calendar, which uses a lunisolar calendar, which adjusts for the difference between the lunar cycle and the solar cycle by having leap months. And so both methods for calculating Easter, which, by the way, if you're going to be celebrating Easter next month on the 2nd, I hope you have a good Easter. If you already celebrated Easter, I hope you have a great Easter. Oh, Leah Phyllis, are you an Eastern Easter guy?
No. I was just cheering because I know people that celebrate it there.
Okay.
So, yeah.
I thought for some reason you were, oh, my Easter's coming up. All right, anyway. But, yeah, so the fact that Easter happens in the spring.
Have a harvest festival in the middle at the start of spring, though, eh?
But it's not a harvest. Easter is neither a harvest nor a sowing festival. It is a festival that, because of when Passover occurs, did accrue to itself some aspects of spring festivals in various cultures. But its date itself is actually determined by the Passover date, which is not at all an agricultural holiday, right? Like, nothing about the Passover meal or the Seder or any of the traditions in Judaism about the Passover are tightly tied to agriculture, except in that the products of agriculture are consumed.
Survival comes down to agricultural yield.
But not in the Passover story.
If it's a festival of eating stuff, well, then basically it's probably eating the last of your last year's crop.
It's specifically a festival of eating quick to make food because you might have to flee from your house at any point, right? There's a reason. So the lamb that you eat at Passover is supposed to represent the lamb that was slaughtered to put the blood over the mantles of the doors so that the angel of death in Egypt knew to pass you by, right? So it was already an animal that you had already killed. You drained the blood to make the sign. It was already there, so you might as well roast it. Okay. The bitter herbs and the unleavened bread are eaten because they're things that you can make right now. And you can just get out of Dodge immediately after dinner. That's why in the Bible it says you're supposed to eat the meal with your staff in your hand and your loins girded, ready to go. It's not a harvest festival or a fertility festival or anything like that. It's a, hey, we need to leave soon festival.
Look, I didn't mean to bring this into a religious discussion whatsoever, but it seems to me like
girding your loins?
Oh, that's actually a fun thing. So in the ancient Near East, people would wear clothing that, like your pants, you didn't have separate slots for your legs, right? You just had sort of a skirt thing. But that can cause problems for like range of motion of your legs. So what you do is you reach back to the end part, like the back part of this tunic thing, and you pull it forward, and then you tie it up with the front part. So that way it hikes up the skirt part, protects your well, your crotch area by having just a whole bunch of extra cloth there. And now you can go into battle with your loins, quote-unquote, girded, because you've tied up those two parts of your garments together to make, essentially, makeshift pants to increase your range of motion.
Oh, right, yeah.
So yeah, there you go. That's girding your loins. Now you guys know. It's like Bible hour with Dapper Dino all of a sudden.
To how to wear your dress. Okay.
Yeah, basically it's how to wear a dress so that you can go into battle. Is basically what it is, yeah.
Yes, definitely. No, I have not translated.
Leo, I think I'm getting some audio from you that is... I think it's you. Leo? I'm going to mute him until he looks back at me. Yeah, it was Leo. I don't know what's happening there. So we are coming up towards the end period. So I do want to make sure everyone who wants to can get in some final points. So we're going to start off with Ross. So Ross, final thoughts.
Yes, well, as this discussion finally devolved into, as we saw as well, is that heliocentrism is basically nothing more than a echo again, Leo. Thanks, mate.
Sorry about that.
Is that heliocentrism is basically a hangover from ancient sun worship and survival, as you're saying, how to plant our crops, when to plant our crops, and all the rest, but somehow made the Earth into an insignificant, tiny little speck that's going around the sun, where that's not the case. The Earth is everything. It is the Mother Earth, that everything that we know and live by comes from. Our bodies come from our housing, our shelter, our food, our breath. Everything comes from the Mother Earth. The Mother Earth is the most significant factor in this flat Earth discovery and awakening. And we know that the Son of God, or the Son, the Father, Son, that gives light and life down onto the Mother Earth, into the womb, creating all the life, is the most important factor of where we get our life from. But it does not mean that the Son is God, or that we should worship it as God, as heliocentrism has done and placed everything around the Sun and turned the Mother into this insignificant tiny speck in space. No, the Earth is everything. The stationary planar Earth is the solution to every single thing that has been plaguing mankind for so long. We've been tricked into false beliefs, and that basically makes us a slave to our own minds and to the people who govern our minds, who rule our minds, the governments who trick us into thinking absolute lies of scarcity, of lack of resources.
We're going to have to start wrapping
this place is infinitely rich, and we have the ability to become part of it if we accept the truth. We live on a stationary planar Earth.
All right. Well, of course, as someone who recently came out as a follower of the spiritual teachings of Kalis the Unforgettable, I do agree that the sun is not a god, because the Klingons slew all the gods, so you shouldn't worship the sun. Because if it were a god, it would have already been killed. So, Brenda, what do you got for us?
This has been interesting. Once again, we see that it's really just flat Earth is really just religion, because that was what we were just told. It's his personal religion, and he refuses. There's a complete refusal to consider anything other than his religion, and any suggestions we make, he just hand waves away and dismisses. So he's a science denier and a globe denier, and it's just an irrational, dogmatic belief in a religious tenets. That's all flat Earth is.
All right. And by the way, I was in fact joking. The whole Kalis the Unforgettable thing was just an April Fool's joke, so don't take me too seriously there. Leo, what do you got for us?
I'm assuming this. I'm sorry, I had something. I was trying to figure out something on my laptop.
We
noticed.
This
is yeah. This is a final.
Yep. Final
meme. Yeah. I thought the debate was respectful tonight, though I do fervently disagree with the position that my opponents took. The Earth is obviously not a sphere. I don't believe that a majority of the people that claim to be flat earthers genuinely believe it. And the reason is because I think that there's, and maybe I'm being overly charitable here, but I think that there are individuals who are smart enough to know that the earth is not flat. I mean, I really don't know what else to say other than that. And like I said, perhaps I'm being overly charitable, but I feel these people are more intelligent than that, because I don't feel there's two reasons why somebody would believe in a flat earth. And that is, number one, that they are so illiterate that they can't understand why the position is wrong, or B, they don't actually believe in it and they claim they do for the attention and the drama that they can stir up. They're essentially a Poe or a troll. Those are really the only two reasons that I've ever seriously encountered when it comes to flat earthers. It's the only two reasons I think anybody would truly be a flat earther. And anybody who enjoys any of the things that I have to say, feel free to check out my YouTube channel.
Absolutely. And actually, I do apologize for not having that linked yet. I did set this stream up very quickly. I will make sure to try to get everyone who was here's YouTube channel in. So that would be Paul, Ross. Brenda, do you have a YouTube channel?
Yes, I do. I have a couple videos on it, but I'm really horrible at updating my channel.
Hey, we'll tell you what. If you want your channel linked, hit me up on Twitter. It probably won't be until tomorrow, if I'm being honest, guys. Sorry.
Okay.
But I will try to add all of those channels in, as well as Leo and David Neff, who did come on. So that'll probably be something.
I put mine in the private chat. Real simple to remember.
That I'll be honest, it's not going to be something I do immediately because
yeah, no, it's all good. It's all good.
I'm getting a little fatigued, so I'm going to close up with my final thoughts, and we're just going to get out of here. I'll play the end credits. I am hopefully doing a marathon stream tomorrow, responding to some more Genesis Apologetics nonsense, because Genesis Apologetics decided to take down like 14 of my videos. So screw those guys.
Wow.
Yeah. Tuesday. They're all back up.
How do they?
Oh, copyright.
How do they do that?
Okay, so they're back up. Okay.
Yeah,
but if it's under fair use, though, right?
So when you make a copyright claim via the copyright robots, YouTube automatically sides with the claimant.
Yeah, but isn't there a penalty, like if you make false claims like that?
Not unless it actually goes to court.
Jesus.
Yeah. Thanks, YouTube.
Jesus.
Yeah, it's pretty bad.
Yeah.
But anyway, they're back up. They are back up, and I'm gonna hopefully do that, assuming I'm up to it, which I do think I will be. I wanted to do it last week, but I was basically I got the vaccine and I hadn't slept well for the past few days, so I was just not up for it. It was basically I was just gonna be a jerk, and I don't want to be a jerk streaming for you guys, so that's why I didn't do it. But then Tuesday will be Eric with Erica. So if you like Gutsick Gibbon and you like us making fun of Eric Hovind while we drink and correct him, please show up for that. That will be at 6 p.m. Pacific, which is 9 p.m. Eastern. Thursday, I'm not positive what'll come out, but I have a few options. There will be a video on Thursday is what I'm saying. Then the next Saturday, I don't know. But the Tuesday after that, we're going to be doing a cryptid tier list. So if you like cryptids, we're going to do a tier list for that on the channel. And that is as far out as I have the channel planned. And yeah, there you go. If you want to, there are links to support the channel. If you can't support monetarily, that's great. Please just like the video, share it on social media if you can. And we're going to hit the end credits scene. And I will talk to you guys later. I want to take a little time to thank my channel members and patrons, especially those pledging $20 or more. Bob Knob, Bent Hovind, Ian Chen, Chris Love, Sphincter of Doom, The Venerable Bead, Patrick Dennis, and Res Instance. YouTube is a very volatile platform, what with fraudulent copyright claims, demonetization, and the ever-decreasing share of ad revenue on the platform. It is very hard to rely on YouTube. My members and patrons help keep this channel going, and without them, the channel wouldn't exist. If you'd like to join my Patreon, the link is in the description, and if you'd like to become a channel member, that link is below the video. It's the join button here on YouTube. Either way, you'll get access to early videos, an exclusive Discord server, and if you pledge enough, 3D assets you can use in your own projects.